Hello everybody, and welcome to a very unique geometry video. So, a couple classes ago, I handed out a small supplemental worksheet that was supposed to sort of connect to 8.4 a little bit. The purpose of this worksheet is to practice something we learned in Algebra 1, a process known as factoring, that we haven't been able to see as much in geometry, just due to the nature of the problems. Your ability to factor is going to be a huge difference maker in Algebra 2. So my goal for this video right now is to make sure that we are familiar with this content and able to replicate it. So let's take a look at this problem. We're trying to solve for x here, and we notice that we do in fact have a triangle that is cut with a line segment parallel to the opposite side. One of the theorems that we learned in this past unit is the triangle proportionality theorem, which says if this exact situation happens, then all these little pieces are proportional to each other. What's proportional to what? Well, as long as those two pieces have something in common with each other, they're proportional. For instance, I could say that 3 and x minus 3 are proportional because they're on the same side. They're along the same length. I could also say that x minus 3 and 2 are proportional because they're on the smaller of the two triangles instead of on the small ends of the big triangle. However you choose to set up your proportion, as long as you are comparing like parts, doesn't really matter too much for the process of the problem. No matter how you set it up, you should get something that looks like this. To solve this, we learn that we have to cross multiply, but that's where we run into a bit of an issue. So 3 times 2 will give us 6, but x minus 3 times x plus 2 is a polynomial problem. Now, if we were in Algebra 1, you guys would probably be able to solve this lickety-split, but that's been a whole year. So let's talk through the process for how we would solve a problem that looks like this. For starters, multiplying polynomials is pretty basic. We learned the process we should use is called FOIL. FOIL, or double distribution in some cases. To do this process, take each term of the first polynomial and multiply it by every term in the second polynomial. So I'll take x times x. I'll do x times 2. X times x is x squared. Be careful. X plus x is 2x. X times 2 is 2x. And now we multiply the negative 3 to everything. So negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. And like we said, this equals 6. When we simplify this polynomial out, we are going to get x squared minus x minus 6 equals 6. And this is where we sort of get stumped. This is where we need to go back through the steps for how to solve a polynomial problem. If you're trying to solve a problem that has an x squared in it, the specific version that we call this is a quadratic. So we are solving a quadratic equation. Quadratic equations are anything that's in the form of ax squared plus bx plus c. And the goal is to get one side of your problem equal to 0. We'll see why in a little bit, but the main goal is to get one side equal to 0. That's easy for this one because we can just subtract 6 from both sides. We end up getting x squared minus x minus 12 equals 0. Well, now we need to solve this problem. And this is where we need to go back to Algebra 1. This is a polynomial in standard form. Our goal is going to be to put it in something called factored form. Factored form looks more like this, where you have x minus some number times x minus another number equals 0. If your polynomial is in factored form, you could just set your first piece equal to 0 and your second piece equal to 0 due to the zero product property. Here, our goal is to change from this form into this. This is where we use a process of factoring. To factor, there's a lot of different ways to do it, but many people have been familiarized with this organizer, a big X to write down some of their thoughts. What you do is try to find two numbers that multiply to make a times c. Again, a is the number in front of your x squared, and c is the number by itself. That adds to make b. So we're trying to think of what multiplies to make a times c and adds to make b. Well, what's a times c? A times c in this problem, c is negative 12, and since we don't see a number in front of the x squared, we can assume that's 1. 1 times negative 12 is negative 12. What's the b value? Well, the b value is going to be whatever number is in front of your x term, just like it is up here. If we don't see a number, we just have a negative sign, that means the number is negative 1. So we're trying to think of two numbers that multiply to make negative 12 and add to make negative 1. If we think about it for a little bit, we realize there's only one pair of numbers that do this. Negative 4 times 3 gives us negative 12. Negative 4 plus 3 gives us negative 1. So that is what we're going to be breaking our polynomial into. We have x squared minus x minus 12 equals 0. Again, this is just what we had from before. The way we break it up is we are going to split our b value, our middle term, into negative 4x and 3x. Because think about it. We can write negative x as just the sum of negative 4 plus negative 3. The rest we'll write down as normal, like so. And now we can engage with the process of factoring. We learned in Algebra 1 that if you have 4 terms, you can factor by grouping. So we group our first 2 terms in parentheses and group our last 2 terms in parentheses. From here, we just see what we can factor out. So what's in common between x squared and negative 4x? Well, both of them have an x in it, so we factor out, or divide by, x. Whatever's left over, we put in parentheses. So if we took an x out of x squared, we'd just be left with 1x. And if we take the x out of negative 4x, we just get minus 4. Similarly, we can do the same thing for the next one. So 3x and negative 12. What can we take out from both of those? Both can be divided by 3. So we divide by 3, and we write down whatever's left over. Once again, we get an x here, and negative 12 divided by 3 is negative 4. You'll know that you've done the problem correctly if you have 2 matching terms in parentheses. Since they do, here's the last step of the factoring process. To finish the factoring, the things that you took out of parentheses, the things that you factored out, become one of your terms, x plus 3. The things that were left behind in parentheses become another term, x minus 4. And we said this is supposed to equal 0. This is now in factored form, just like up here. The final thing to do is this. If you have something in factored form, and again, I'm just going to rewrite it over here, x plus 3 times x minus 4 equals 0. If you have something in factored form and you're trying to solve for x, just set each piece equal to 0. So set x plus 3 equal to 0, x minus 4 equal to 0, and solve. It's clear that x in this one would have to be negative 3, and over here would have to be 4. So these are your 2 possible x values, negative 3 and positive 4. But something doesn't feel right. As I look at this problem, there's an x value that actually wouldn't work for this. Can we think of which one it is? If x was negative 3, then this side here, x minus 3, would be at length negative 6. And we can't have a shape with a negative side length. So we wouldn't list this as one of our answers in context, even though it works mathematically. x has to be 4. So x equals 4 is our final answer for this one. Cool. Let's do number 2. I'm going to walk through number 2 a little bit quicker, but not much, just because at this point we see the process. So step 1 is to set up your proportion. Here we have an angle bisector, so according to the triangle angle bisector theorem, we know that we can compare any two similar parts across these two triangles as well. Me personally, I'm going to compare x minus 1 to 10. They're proportional because they fit the same niche. They're both part of the bisected, but the line that's been cut up, equals x plus 2 over 3x minus 2. And we just need to cross multiply to solve. So we'll do x minus 1 times 3x minus 2 equals, on the other side, we have 10 times x plus 2. Oh boy, we've got quite a bit of multiplying to do. So let's do it step by step. X times 3x is 3x squared. X times negative 2 is minus 2x. Negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2. And this will equal 10 times x, which is 10x, 10 times 2, which is 20. I'm going to combine the like terms over here, so we end up with 3x squared minus 5x plus 2 equals 10x plus 20. And again, the rule is, if you're looking to factor something, if you want to solve that problem, you need to get one side to equal 0. So let's move all the terms from the right side over to the left with the other ones. I'll subtract 10x from both sides, and I'll also subtract 20 from both sides to get the following. 3x squared minus 15x minus 18 equals 0. This is our factorable polynomial. This also is a brilliant time to bring up the following fun fact. Fun fact as in necessary thing that we should always try and do. Notice that there's something weird about this polynomial. All of these terms are multiples of 3. If there is a number that you can factor out of your problem, before you do any sort of factoring process, you must do so. For some problems, you can probably factor at the end and it'll still give you the same answer. But for many, factoring at the start is the only way to do it. So the good rule of thumb is, if you notice you can factor something, do it right away. I noticed that all these can be divided by 3, so the way we factor out the 3 is just by dividing all the terms by 3 and leaving it outside in parentheses. If I took 3 out of all these terms, we'd be left with x squared minus 15x, I just did a huge mistake. X squared minus 5x, because again we divided 15 by 3, minus 6, and that equals 0. And this is much easier to factor than this. Now we're ready to factor. I'm going to do this factoring without using the big X because in Algebra 2, we won't be using it as often, and it's usually quicker if you can avoid using the big X. But I will talk about my thought process. I need to split negative 5x into two numbers. These numbers must multiply to make our a value of 1 times negative 6, so they have to multiply to make negative 6, and add to make negative 5. Let's think, what multiplies to make negative 6? Well, we know that 2 and 3 make 6, but negative 2 times positive 3 would give us this. It wouldn't give us this. Same vice versa. So there must be another factor. Instead, realize that to multiply and get negative 6, couldn't we just do negative 6 times 1? So I'm going to say that this is 1x minus 6x. Again, because 1 times negative 6 makes negative 6, and 1 minus 6 gives us the negative 5 in the middle. So our problem becomes 3 parentheses x squared plus 1x minus 6x minus 6 equals 0. Notice this 3 is just outside of the problem now. It is not going to interact with our problem in any way because we took it out already. We already factored it. It means that when we have our final factored form, there's just still going to be a 3 hanging out there. But we still have to continue factoring, so we have to factor by grouping. I'm using brackets here instead of parentheses to help distinguish, but you can use just double parentheses if you really want to. So my 3 isn't bothering anybody, it's just chilling out. But the question is, what can I pull out from my first pair of terms? X squared and 1x both just have an x involved. So we would pull out an x. A good rule of thumb is if there's nothing you can pull out, try pulling out 1. We got lucky in this case where the order that we did this problem made it very easily factorable. But in the future, if you ever can't factor anything, always just factor out a positive 1. We end up with x, and what's left over is x plus 1. Here, notice the term in front of our x is a negative 6. If the first term that you're trying to factor out of is a negative, take the negative out with it. I'm factoring out a negative 6. And watch what happens when we do so. Negative 6x divided by negative 6 is positive x. Negative 6 divided by negative 6 is 1. These two match. If we didn't take out the negative, they wouldn't match. So that's how we would know we did it wrong. So our final factored form is going to be 3 times our first set of parentheses is whatever we took out, so x and minus 6. Our second set of parentheses is whatever's in common, x plus 1. And that has to equal 0. From this step, it's pretty easy to see what x should be. If you wanted to, you could set up equations where both of these equal 0, but I'll just write down the two possible answers. Either x equals 6 or x equals negative 1, because those are the values that would make the parentheses 0. Again, we ask, do these numbers make sense? And in this case, negative 1 does not make sense. I don't want a side length that's negative 2 long. So our answer is just going to be x equals 6. Very nice. Let's flip to the page. Now we are asked to solve for x, then find all the measures of the sides. With this problem, here is my recommendation. Don't get distracted by these lengths here. These are not where we're going to try and find our comparison. In fact, I threw these lengths in here just sort of randomly almost. Let's set up an equation or a proportion with these lengths. I know it'll take longer, but trust me, it's going to be a better alternative. We'll see why in a second. So, let's do 2x minus 3 over x plus 1. Hope you'll excuse me using just a regular black pen for this one. And 2x over x plus 5. Now we're going to cross multiply. So on one side, we're going to get whatever 2x minus 3 times x plus 5 is. And on the other side, we're going to get whatever 2x times x plus 1 is. 2x minus 3 times x plus 5. We've just got to double distribute, or FOIL. This is 2x squared plus 10x minus 3x minus 15. Sweet. On the other side, we only need to distribute once. 2x times x is 2x squared. 2x times 1 is 2x. We notice that some terms can be combined on our left side, so I'm going to get 2x squared plus 7x minus 15 equals 2x squared plus 2x. And from here, we just need to move all of our terms to the other side. So I'll subtract 2x squared from both sides. And, oh, the 2x squares actually cancel. And I'll subtract the 2x. It's kind of convenient. So what we really end up with is 5x minus 15 equals 0. Folks, this is super, super easy to solve. This one is very, very quick. All we need to do is just solve for x like a normal algebra problem, because there's no x squares to deal with anymore. This won't always happen, but it is a fun convenience when it does. We get 5x equals 15. Divide by 5. X should equal 3. So if it asks you to find the measures of all the sides, just plug in 3 for all of your x's. 2x minus 3. 2 times 3 is 6. Minus 3 is 3. That's this little side. X plus 1 is going to be 3 plus 1, which is 4. X plus 5 is going to be 8. And 2x is 6. And if we wanted to check our answer, take a look at these proportions, folks. 4 times 2 gives us 8. 3 times 2 gives us 6. It's proportional. So that's one way you can check your answer. Problem number 4 is a little trickier, though, because we are given not a triangle necessarily, but a shape with all these perpendicular markings, or these right angles, I should say. Recall that there is a theorem we learned back in Unit 3 to help us with this. The lines perpendicular to a transversal theorem says, if you have multiple lines that are perpendicular to the same line, those lines must be parallel. So we really have not only 3 perpendicular lines, but all 3 of those lines also must be parallel. Which means we can apply another one of our theorems. We learned a theorem that says that, hey, when you have multiple lines that are parallel to each other, they are still splitting up a shape proportionally. So we are just good to go and set up equations. Me personally, I see the x squared minus 16 and x minus 4 can be compared to x plus 4 and 2. So I'm going to set up this proportion. And I'm going to show you another trick here that could help us. And it's really going to make this way, way easier. I'll also show you the long way if you'd like. Before we start cross-multiplying, I wanted to share something with you that could make this problem a breeze. And I mean an absolute breeze. You could multiply and distribute, and you'll end up with something fancy. But I want to look at x squared minus 16. This is something we learned in Algebra 1. It's a pattern, a special pattern called a difference of squares. Anytime you have a difference of squares, when you factor that difference of squares, watch what happens. Let's say I was trying to factor this. Well, I would end up needing 2 things that multiply to make a squared, so I know my first terms have to be a. I need to multiply 2 things together to make negative b squared. So you know they got to be 2 b's, but to get a negative b squared, one's positive, one's negative. This is the difference of squares pattern, and it's a shortcut that you're allowed to use anytime both of your terms in a polynomial are perfect squares. We can jump straight in and factor this if we wanted to, and it might reveal something interesting about the problem, or more specifically about how Mr. Strager made this problem so quickly. I can factor x squared minus 16 as x plus 4 times x minus 4. Since the square root of x squared is just x, and the square root of b squared is just b, or, sorry, the square root of 16 is just 4. I end up getting this. You might say, Mr. Strager, this looks more complicated, not less complicated. Sure, but isn't there something we can simplify here? An x plus or minus 4 on top of a fraction, and on the bottom, will cancel out. We end up with just this. X plus 4 equals x plus 4 over 2. Heck, if I was to multiply by 2 on both sides, for instance, to get rid of the fraction, I would end up getting 2x plus 8 equals x plus 4. Simplifying this out, I get to subtract x from both sides, and I'm going to minus 8 from both sides to cross these off. 2x minus x is just x. 4 minus 8 is negative 4. We've done it. We didn't even need to do any big factoring problems. This is just x equals negative 4. So the question that was asked here is, find all the measures of the sides, and are these measures realistic? For some of them, the answer is absolutely. For some of them, the answer is absolutely not. Because think about it. If x was negative 4, this side would be negative 8. It's not possible. If x was negative 4, this side would be 0. That's not possible. And this one would also be 0. So, in reality, this x value is not a realistic x value for us. It's just not practical for us to even have on the paper. But we did solve nonetheless. I hope this video has showed you a couple of tricks with factoring and hopefully refresh your memory a little bit on them. Factoring using the AC method. Factoring by taking out a greatest common factor, and then, well, factoring by the AC method. And difference of squares, that we saw here, are 3 of the biggest ways of factoring. If you need further practice or have any other questions, please don't hesitate to reach out. I want you to succeed, and I want you to get ahead if possible as well. Thank you so much, and have a great rest of your day.